All right, this is a video on solving quadratic equations by factoring and by graphing, and we'll start with an introduction and then do a few solved examples. So some terms to start off with, and these are all roughly synonyms of each other with a few differences, but the terms we'll be looking at are solutions, zeros, roots, and x-intercepts, all in the context of quadratic equations or quadratic functions. So let's first think about this in terms of what a solution might be. So we have this particular quadratic equation right here in one variable. There's only an x variable. It happens to be equal to 0, and we might want to solve for what x would be, okay? And that would be the solution to this quadratic equation. We can also think about what zeros, roots, and x-intercepts are. And in this next line, what's highlighted in orange, we have a quadratic function, a y equals 2x squared minus 3x minus 2. We could graph that up as a parabola, and I'm showing it graphed to the right of your screen right now. And if we are looking for what's called the zeros or the roots or the x-intercepts, in this case we are looking for the places where the parabola crosses the x-axis. Okay, and those locations, those x values where the parabola intersects the x-axis, are also the solutions to the initial quadratic equation we had that's highlighted in yellow. Okay, so the solutions to this yellow equation are the x-intercepts of the parabola. Okay, so when we talk about solutions, typically we talk about when a quadratic equation is equal to 0. And when we talk about zeros, roots, or x-intercepts, we talk about the x-intercepts or the locations on a graph where the parabola might cross the x-axis. Okay? And it's a big challenge, a big task, and there are many ways of approaching this task, but it's a big task to find those locations, to find the x values where y is 0, to find those x-intercepts. And that's what we'll be working with today through a factoring process. But first, I want to look at the zero product property. And the zero product property basically says if we have two pieces, A and B perhaps, whose product is 0, then either one of those, so if A times B is 0, then either A or B, or both, are equal to 0. Okay, so if we have the product of two terms, either simple terms or complex terms, if the product of two terms, no matter how complicated they are, is 0, one or both of them must be 0. It is impossible to have a product equal to 0 where neither of the two factors are 0. And that's going to get us quite a bit of utility here as we're trying to solve these quadratic equations. So let's look at this first one. Solving by factoring. A beginner algebra student might think, okay, let's add 24 to both sides, but then we get stuck. What do we do with the 5x? What do we do with the x squared? The way we want to solve these is by factoring, and we can factor this quadratic trinomial into the product of two binomials, and it will end up looking like this. X minus 8, x plus 3. I won't do any reminders on factoring here. There are other videos for that. But now what we've done is we've factored our quadratic expression into the product of two binomials. But the key thing, it's the product of two pieces. So we have an orange thing times a red thing is equal to 0. So either the orange product, the orange factor, is 0, or the red factor is 0. So one option is x minus 8 equals 0, which means x is 8. And the other option is x plus 3 equals 0, which means x is negative 3. So we've actually solved it then. Okay, so we have two solutions, and our solution set is negative 3 and 8. Okay, so either of those numbers, negative 3 or 8, are valid solutions to the original quadratic equation. The key thing you need to make sure you do is force your equation to equal 0. Okay, this won't work if it's equal to something else. So here you can see 7x is equal to 15 minus 2x squared. We don't have anything equal to 0, so let's make some stuff equal to 0. So I like getting positive x squared terms, so I will add 2x squared to both sides. And I will also subtract 15 from both sides. And what that's going to get us is a bunch of canceling on the left, or excuse me, on the right, where everything's going to then equal 0. And on the left, we have a 2x squared plus 7x minus 15 is equal to 0. Okay, so we've done the first step. We have factored our quadratic expression, or excuse me, we've set our quadratic equation equal to 0. Our next step is to factor. And this is a little bit of a harder step, but we are going to factor it into a 2x and an x, and we need to think of factors of negative 15 that would result in a positive 7x if we were to FOIL. So I am going to get a plus 5 and a minus 3 right there. And we do a quick FOILing to check 2x squared, yep, plus 7x minus 15. So the math checks out, the multiplication checks out. And so now we have two options. One option is 2x minus 3 equals 0, and the other option is x plus 5 equals 0. So the first option means that x equals 3 halves once we solve for x, and the second option means that x equals negative 5. So our two solutions are negative 5 and 3 halves are the two solutions to the original quadratic equation. All right, and we can solve these equations by graphing as well, and we're simply looking for a series of x-intercepts that would be the solution to the quadratic equation. So let's actually get it into a nice form first, this next example. So I am going to subtract 2 from both sides, and I get 3.5x squared minus 18x minus 2 equals 0. Okay, and I'm going to think of that as a graph of a parabola. Y equals 3.5x squared minus 18x minus 2. Now I could try to factor this and solve this by hand, but our task here is to solve this by graphing, so that's what we'll do. Okay, so we're going to go to Desmos and graph this parabola, and we are going to look for the x-intercepts. Remember, an x-intercept means that y is 0. And so that would then solve the equation we're looking for. Okay, if we plug in 0 for y, it would solve that equation right there. Okay, so let's go ahead and go to Desmos real quick and graph this up. So we have y equals 3.5x squared minus 18x, and it was a minus 2, I believe. Okay, so we have a graph of our parabola that you can see right there. And we are looking for the x-intercepts. And so those are the two x-intercepts right there. And let me go ahead and copy and paste that image back into my Note app. And then we can, once we paste that in, you'll see that we have that these are our two solutions. So the two solutions are right here and right here. X equals, let's go back and grab it from Desmos, negative 0.11 and 5.25. So negative 0.11 and 5.25. So those are the two solutions that we determined from graphing on Desmos. Okay? And that is a great place to stop right there.